Hello, this is Denton Yoder. I'm the computer systems engineer for biological systems engineering. I wanted to show you some tools you can do in AutoCAD to help you do 3D printing. First thing I want to mention is that anything you draw in AutoCAD, we should be able to 3D print within reason, of course. You can draw some really weird stuff. But the commands you need to learn, of course, you need to learn the 2D AutoCAD commands, and you can learn those easily by watching the first few videos of the BSE 2304 CAD class, or from what you've already learned in freshman engineering. But what I'm going to teach you are just a couple extra commands. One of them is the region command. Right now I have a part that's a bunch of lines, arcs, and circles. If I do the command region, R-E-G-I-O-N, and do a box around this part, it says 2 regions created. I'm going to do the same thing with the 2 circles on the right. 2 regions created. I can subtract from the outer circle, enter the inner circle, and now this is a surface or a solid. Do the same thing with my paddle wheel. I can subtract from the outer boundary, enter the inner boundary. If I now turn on some colorizing in AutoCAD and look at it in 3D, is that the spin command? I made a flat disk. Another command in AutoCAD is extrude. So if I said EXT for extrude, this piece 0.5, I just extruded that a ½ inch. The disk I'm going to extrude 0.0625, just because I want a thin disk. Now, why did I do this? I can move the thin disk from the center of the top inside of the hole to line up with the center of the bottom circular radius, and maybe clicking on the inside section here would do better. And I can copy that, 0 in the X, 0 in the Y, and 0.5325. Is that what I did it? No. Move it again. Oh, I did 0.0625. I need to move that up another 0.03. Move this one 0, 0, 0.03. There. 0.0, excuse me, 0, 0, 0.03. Okay. I should have probably just snapped center to center like I did on the bottom. But anyway, what I just did was I made a sandwich with 2 of those discs and 1 paddle wheel. Now I can do the command union. Union will take solids that you make and glue them all together into a single solid. So now I have a solid that is a paddle wheel, and water can go in the cells and it'll come out on the backstroke. Just for kicks, I like to look at some of the other options and go to a continuous orbit and set it spinning and watch it spin. I just find that fun. Okay. Having created a part, I really need to save it. It's going to be a drawing. But before I do save this drawing, I drew it in inches. My 3D printer is metric. So the easy thing for me to do is to scale my part 25.4 times, and now my part is in millimeters. I scaled it up a factor of 25.4 to go from inches to millimeters. Okay, now I can also do a command called export. The export command gives me different options that I can export. I think an STL does a good job. If I export an STL file, and I'm going to put it on my desktop and call it wheel, select my part, enter, done. Now I should have on my desktop a copy of the wheel in an STL format. There's software you can get if you search for Cura, C-U-R-A, and Ultimaker. The Ultimaker.com site has free Cura software I can use to post-process solids I create into the code I need to go to my printer. If I look at the printer we have, BSE bought an Ultimaker 2 Plus. So if I install the Cura software and tell it that I have an Ultimaker 2 Plus, the two other things I need to watch closely are the material and the nozzle size. So the material is what material we have in the printer. Right now, when I'm recording this, we have PLA material in there, but it can use other material. And the nozzle size is also important so it knows how much material to put down at a time. The current nozzle is a 0.4 millimeter. You will probably want to talk to Laura Lehman and verify the material and the nozzle size when you're doing your job. You also can have a lot of different configurations for infill and things like that. But getting there, I'm going to go to my desktop, grab my wheel, and I now have the wheel set up to print in my Ultimaker software. The computer is going to do some sketching on the inside of this part. I drew it hollow, but it's going to need to do some sketching on the inside in order to support the top part of that wheel. I'll let it do it itself. I'm fine with that. So now I'm ready to prepare this. Let's see. File, export, G-code. File, export, G-code, save, and it'll create the G-code you need to produce this part using your settings. A build plate adhesion probably is not necessary for this part because it has a big adhesive space on the bottom. A build plate adhesion will give it a little bit of a strip on the outside of your part to hold it down. Actually, I'm going to do it again and turn that off because I definitely don't need it because I have a big flat plate on the bottom that would adhere to it just fine. I'm going to tell it to generate support. Generate structures to support parts of the model which have overhangs. So I'm going to go ahead and turn that on because it is going to need supports on the interior of this part. If your part doesn't have an open interior, you may not need that. You do also need to look at the rotation that you've set your design up to print because you're going to want a wide base and a short height typically to do your part. But you'll get the hang of that as well. Let me do a file export and do it again. And so now, I didn't want a MP3 or whatever that is. Export, switch it to G-code again, save, yes. I've exported my G-code. What my process will be now is to write that G-code out to a SD card. The Ultimaker 2 Plus has an SD card slot. You'll put your SD cards in there. When you turn the machine on, the switch is in the back left. You'll get a menu on screen. It will read your card, and you can use the thumb wheel to spin around to select your file and then push the button in to print your file. So this is an SD card reader. Put your G-code on there, and it'll print your design. Have a nice one. Bye.